All right, so we're going to work through just a bunch of practice problems associated with binomial distribution probability. So let's see here. If x is a binomial random variable, compute p of x for each of the following. So this is a standalone situation here. It's saying that n is 8, so the number of trials is 8. They want to know what is the probability when x is equal to 5, and the probability is equal to 0.37. That means the probability of success is 0.37. We want to know what is the probability of x. That means what is the probability of 5. And so we're going to go, so n is 8. Probability of success is 0.37, and we just want to know the probability when x is equal to 5. So we're going to go to Minitab here, and we're going to go to Calculate. We're going to go to Probability Distributions. We're going to select Probability Density Function. We're going to select Distribution Binomial. We're going to do a single value, and this question, number of trials, n is 8. Event probability, let's see, it's 0.37. All right, so we're going to put in 0.37. And then the value we're looking for is x equals 5. And then we just hit OK, and that's our answer. Let's see, our answer is 0.097, and then we're going to go to 1. We're going to do 0.0971. So this is going to be 0.0971, okay? Now let's move on to part B. Part B says when n is 17 and the probability of success is 0.5. By the way, probability of success 0.5, that's the same thing as flipping a coin. Okay, a coin flip is a binomial random variable, and probability of getting heads is 0.5, and probability of getting tails is also 0.5. So whenever you see a binomial random variable and p is 0.5, that's the same thing as a coin flip. Okay, so n is 17, p is 0.5. We want to know the probability of getting exactly 14. So this is like the same thing as saying the probability of flipping exactly 14 heads on 17 coins. All right, so we're going to go back here. We're going to go to Calculate, Probability Distribution, Density Function. We're already on binomial. Number of trials is 17. Event probability is 0.5, and we want to know the probability of getting 14 successes. So we're going to hit OK, and it looks like the probability is 0.005, rounded to, because it's 518. That 8 is going to round that 1 up to a 2, so it's 0.0052. So 0.0052, okay? Now let's do this third one here. It says n is 3, so 3 trials. What's the probability of 0 successes when the probability of success is 0.21? Okay. All right, so we're going to go here, calculate, probability distributions, probability density function. Binomial is already here. Number of trials is 3. Probability of success is 0.21. And we want to know the probability of getting 0 successes. Hit OK. And the probability is 0.493. So 0.493. I hope that seemed very easy, because it actually is really easy once you practice doing it, once you get used to doing it, okay? Now we're going to try some other questions. Now we're going to calculate some means and standard deviations and variances from binomial random variables. So if x is a binomial random variable, compute the mean, standard deviation, and variance for each of the following. If n is 11 and p, the probability of success, is 0.63. Now I want to remind you that in order to calculate the variance, we're also going to need q, and q is 1 minus p. So 1 minus 0.63 is 0.37. Now I want to remind you also that the mean is calculated by doing n times p. So the mean is simply going to be 11 times 0.63. Okay, we can do that in a calculator. 11 times 0.63, 11 times 0.63 is 6.93. So the mean here is 6.93. the standard deviation, excuse me, that's the variance. Standard deviation, we can't calculate that until we have the variance. So we need the variance first. And let me remind you that the variance is going to be n times p times q. So it's going to be 11 times 0.63 times 0.37. So 11 times 0.63 times 0.37. And that's going to be 2.5641. 2.5641. And then the standard deviation is just simply the square root of the variance. So we need the square root of 2.5641. Square root of 2.5641. And that is 1.601, and we're going to put a 3 here. This 8 is going to round this 2 up to a 3. 1.6013. 1.6013. Okay? All right, let's try this part B now. In this one, n is 6, p is 0.5. Remember, when p is 0.5, that means q is also 0.5, because 0.5, 1 minus 0.5 is 0.5. Remember, this situation is the same thing as a coin flip, okay? All right, so the mean is going to be, remember that the mean is n times p. So the mean here is just going to be 6 times 0.5. Well, that's an easy one. 6 times 0.5. 0.5 means half. Half of 6 is 3. So the mean is just 3. And now the variance is n times p. That's the mean. I don't know if you noticed that here, but n times p is the mean. So calculating the variance, you just take the mean and then multiply it by q. So we're going to take the mean, which is n times p, and multiply it by 1/2. Well, 1/2 of 3, that's 1.5. And so the variance is 1.5. And so now the standard deviation is just going to be the square root of 1.5. So let's go to the calculator. We'll do the square root of 1.5, and that is 1.2247. 1.2247. All right, great. Now let's do this part C. So a few more trials. We've got 23. N is 23. P is 0.41. We're going to need Q. So Q is 1 minus 0.41. 1 minus 0.41 is 0.59. You can check it in a calculator. So mu is just equal to n times p. So 23 times 0.41. 23 times 0.41. And that is 9.43. So 9.43. And then the variance, again, is n times p, which is the mean, 9.43, times q. So we're going to do 9.43 times 0.59. Now, be careful about doing that, because you really, if you had to round the mean, if you had to round this number, then you should not just use this rounded number. You need to use the original numbers. But since this is not a rounded number, this is the full number, 9.43, we can use that number and multiply it by 0.59. So 9.43 times 0.59, and that gives us 5.5637. 5.5637. Okay, and now we need the standard deviation. We'll just do the square root of 5.5637. So square root of 5.5637, and that's going to give us 2.3587. 2.3587. 2.3587. Okay. All right, and that's some practice at calculating the mean, variance, and standard deviation of a binomial random variable. And now we're just going to do some practice for cumulative probabilities for a binomial random variable. All right, here's some practice. If x is a binomial random variable, compute p of x, the probability of x, for each of the following situations. Well, here, n is 6, p is 0.71, and we want to know the probability that x will be less than 2. Well, less than 2 is just 0 and 1. So we want to know the probability of 0 plus the probability of 1. Okay? And why aren't we including 2? Because this does not say or equal to. It just says less than 2. So we're not going to include 2. And none of the other numbers are less than 2, just 1 and 0. So we're going to go to Minitab and we're going to do n is 6, p is 0.71, and then we're only going to identify the probabilities of 0 and 1, and then we're going to add them together. So we're going to do calculate. And you know what we could do is we could actually use C1 here. We could put 0 and 1 in C1, and then we can go to calculate. We can go to probability distributions, probability density function. Number of trials was 6, and the p was 0.71. Let me confirm that. 0.71, n is 6, yep, sure enough. And now we're going to change the form of input into a column. And so we're going to put the values in from C1, binomial distribution, and we're going to hit OK. All right, so we have the probability of 0 is 0.0005948. So 0.0005948 plus probability of 1 is 0.0087377. 0.0087377. Make sure there. Yep, I got that right. And hit enter. And our answer is 0.0093. 0.0093. All right. Now this one, part B, it says if n is 11 trials and the probability is 0.5, and remember 0.5 is the same thing as a coin flip, then what is the probability that x is greater than or equal to 8? So this one's going to be, it's going to include 8 and then everything larger than 8. So that's 8, then 9, then 10, and 11. So it's going to be the probability of 8 plus the probability of 9 plus the probability of 10 plus the probability of 11. Okay, and so let's go to Minitab, and what we're going to do is in C2 we're going to include 8 and 9 and 10 and 11. Okay, and then we're going to go to calculate, probability distribution, probability density function, and I believe our number of trials was 11 and our event probability was 0.5, because I made that comment about the coin flip. We're going to get our values not from C1, we're going to get them from C2. I want to make sure we have a column of values up here, and then when we hit OK, we should get 4 of them, and we do. 8, 9, 10, and 11. So we have, let's go ahead and put these in a calculator, 0.0805664. 0.0805664 plus 0.0268555. 0.0268555 plus, now the probability for 10 is 0.0053711. 0.0053711. Last one, probability of 11 is 0.0004883. 0.0004883, and we'll press enter, and we get 0.113. Now this says 2, but this 8 is going to turn this 2 into a 3, so it'll be 0.1133. So this one will be point equals 0.1133. Okay. All right, this last one here, part C, says n is 7, probability of success is 0.38. Then what's the probability of x being between 2 and 5? Now, this says x is greater than or equal to 2, so we're going to include 2. But this says less than 5. It doesn't say or equal to 5, so we're not going to include 5. So this is going to be the probability of 2 plus the probability of 3 plus the probability of 4. Okay, and p is 0.38 and n is 7. So let's go back over to Minitab. And let's use a new column here. We'll use C3, and we'll do 2 and 3 and 4. And then we'll go to Calculate, Probability Distributions, Probability Density Function. We'll get our values from C3. There we go. Our number of trials is 7, and let's see, our probability is 0.38. So we're going to put 0.38 here, and then we'll go ahead and hit OK. And look at that, we get three different probabilities, the one for 2, the one for 3, and the one for 4. And so we're going to add these together. And so we're going to do, for 2, it's 0.277808. 0.277808 plus, we've got 0.283782. 0.283782 plus, and then we have 0.173931. 0.173931. Is that correct? 931? Yep, sure enough. And we hit enter, and we get 0.7355. So this one is going to be 0.7355. And so now, if you've had a little bit of trouble with these practices that we've done in this particular video, I recommend that you go back through this same video and try all these problems again. Maybe look at them before the answers are there, try to do them, with the calculator or in Minitab, and I think you'll get better and better at this.